morning, good afternoon, and a warm welcome to everyone joining us today. Whether you're with us from Zambia, from Mauritius, or tuning in from elsewhere around the world, it is a great pleasure to open this important 3-day webinar series focused on energy efficiency in buildings with a spotlight on our two focal countries of Zambia and Mauritius. We are delighted to see such a diverse and engaged audience, which includes experts, practitioners, policymakers, and most importantly, students. This tells us one thing loud and clear. There is a growing momentum and shared commitment to improving how our buildings perform and how together we can shape a more sustainable future. We are especially grateful for the participation of key representatives from the Ministry of Infrastructure, Housing and Urban Development from Zambia and the Energy Efficiency Management Office in Mauritius, whose leadership and insights will be vital to our conversations. We also thank our guest speakers from the International Finance Corporation, Zambia's National Council for Construction, Government of Ghana representative, and representatives from the IPPR Engineering Corporation from China. They will be bringing their global expertise and local experience into the dialogue. Over the next 3 days, we will explore practical solutions, innovative technologies, and policy frameworks that can drive real impact on the ground. Most importantly, this webinar is a platform for learning and exchange. So I encourage all of you to actively participate, ask questions using the dedicated icon, and share your perspectives. Thank you once again for being here, and let's get started. The webinar series is part of the broader Global Platform for Urban Climate Neutrality project, or GPUC project. This initiative serves as a central hub supporting cities in emerging economies with access to knowledge, technical solutions, capacity building, and implementation support, all aimed at accelerating energy efficiency efforts. This project is supported by DANIDA under the Danish Foreign Affairs Ministry, as well as DINA, the German Energy Agency. And UNEP CCC, where my colleagues and I are participating, are the implementing partner. Today's agenda is designed to lay down the foundation for the rest of the series by focusing on the fundamentals of energy efficiency in buildings. We'll explore core concepts, global trends, and current landscape in Mauritius and Zambia. This will set the stage for day 2, which we will delve into the policy and regulatory frameworks supporting energy efficiency, and day 3, which will focus on practical implementation and capacity building specifically tailored for architects and engineers. We'll begin with an introduction to energy efficiency in buildings, starting with a global overview, followed by context-specific insights from Zambia and Mauritius, provided by MIHUD and EEMO. Next, we'll explore key efficiency strategies for building design, focusing on practical, real-world approaches that can be implemented in various settings. This will be followed by a session on the application of the EDGE tool across Africa, presented by the IFC. To conclude, we'll bring together our expert speakers for a panel discussion to reflect on the themes of the day and finish with a brief interactive quiz. So let's begin with the first session of today, which is the overview of building energy efficiency and global trends. The figure in this slide represents the global sectoral breakdown of final energy consumption in 2022. As you can see, the building sector, which includes energy used for construction, heating and cooling, lighting and appliances in both residential and commercial spaces, accounts for over 30% of the global final energy use and around 26% of global energy-related emissions. That's more than a quarter. And this demand is projected to grow significantly, especially as global floor area increases, primarily in urbanizing regions with Africa leading the way. Rising incomes are also increasing the demand for energy-intensive appliances like air conditioners. And because buildings and their systems often last for decades, the choices we make today in terms of design and equipment will shape energy consumption for generations. That's why it's essential to consider energy efficiency measures from the start to reduce long-term energy use, lower emissions, and stay on track with our climate goals. In the African context, the building sector is especially significant. It accounts for 61% of the final energy consumption and more than 32% of the energy-related CO2 emissions in 2018. And this figure excludes emissions from the production of key building materials. Emissions growth has been driven by an increase in population and a rise in GDP, both of which have fueled greater demand for built space and energy-consuming services. These trends are expected to intensify, and Africa's population is projected to grow by 63% by 2040, and its economy could more than easily double. At the same time, Africa faces several compounding challenges, such as high energy costs, increasing vulnerability to climate impacts, and also hydro resources are declining. Reducing fossil fuel dependency is critical. As of now, fossil fuels supply more than 58% of Africa's total energy needs, and this highlights the urgent need for energy efficiency. Some of the efficiency benefits are covering a wide range, and they go beyond just energy savings. It enhances energy security by reducing reliance on imports, it cuts greenhouse gas emissions, and eases pressure on public budgets and energy prices. For households, this means lower bills while also increasing the value of properties. Energy-efficient buildings contribute to better health and well-being through improved indoor conditions such as temperature, air quality, and noise control. It also directly aligns with several important Sustainable Development Goals, or SDGs, such as affordable and clean energy, sustainable cities and communities, by improving energy access and reducing consumption. And it also contributes to climate action through emissions reduction. To drive energy efficiency forward, global investment in the sector rose by 14% in 2022, reaching over $250 billion USD. And this was largely driven by major markets such as the US, Germany, and Italy. In Europe, rising geopolitical tensions accelerated energy efficiency efforts for energy security, while in the US, the Inflation Reduction Act began to also influence the market momentum. However, investments fell in other markets, such as China, due to a 10% drop in construction activity, and this slowed the progress towards green building targets. Looking ahead, high inflation, tighter monetary policies, and the phase-out of subsidies in regions such as China, Europe, and most probably the US is expected to dampen investment. Despite recent growth, current levels still fall well short of what's needed to meet our climate targets, and therefore investment must more than double just to be able to stay on track. Around the world, countries are stepping up with targeted policies and regulations to scale up building energy efficiency and reduce emissions. The EU has set ambitious targets to boost energy performance in buildings, aiming for a 16% improvement in average residential building stock by 2030 and up to 22% by 2035. To reach these goals, the EU is introducing zero-emission standards for all new buildings and requiring the calculation of whole life cycle emissions in new construction. So this pushes for both energy efficiency as well as carbon reduction across buildings' lifespan. India, on the other hand, has set sector-wide targets to boost energy efficiency across industry, buildings, and includes appliances and transport and other areas. These efforts are projected to reduce energy consumption by 89 million tons of oil equivalent by 2030 compared to business as usual scenario. And this makes a significant contribution to the country's climate and energy goals. China is also advancing sustainable urban development by requiring all new urban buildings to meet green building standards. Public institutions and factories must cover at least 50% of the available rooftop space with solar panels and boosting on-site energy production. The country also plans to replace 8% of urban building energy use with renewables and renovating 200 million meter square of existing buildings for better efficiency. Heating networks will also be upgraded to reduce heat loss by 2%, and renovated buildings are expected to cut energy use by 30% in residential and 20% in public buildings. Now that we have reviewed the global overview of energy efficiency, it's time to focus on the importance in specific context of Zambia and Mauritius. So I would like to invite Mr. Oliver from the Ministry of Housing and Urban Development of Zambia to share Zambia's perspective. So Mr. Zulu, the floor is yours.
Thank you very much, Trupit. Everybody, good morning and welcome to this session. My session will primarily just try and bring the energy perspective into focus because some of us may be aware that Zambia experienced a huge energy deficit, and we're still anyway experiencing a huge energy deficit. And my presentation is basically something that just brings into focus some of the energy plans that have been put in place as a country, especially focusing on our integrated plan for energy efficiency, or rather plan for energy consumption. So this is an integrated resource plan, which basically Zambia has embarked on, as presented by the Ministry of Energy, and we're taking a leaf from that and be able to share with everybody else what exactly we're doing. Primarily, this is just a cover. The overview of my presentation is basically going to look at the integrated resource plan, basically for a climate resilient Zambia, some of the impacts and changes of the energy sector, and most importantly, we'll also look at some targets and a framework of how this implementation plan will augment through. So the overview is that our 8th National Development Plan basically has set targets for how much power we expect to have in the rural areas as well as in the urban areas by the end of the plan. The target is to have 51% of the rural areas and 100% of the urban areas under power. But with the current situation, that hasn't really happened that much. And further to this, the Ministry of Energy, of course, introduced the Integrated Resource Plan in February of 2024, making a significant step in Zambia's long-term energy planning. So the RSP, of course, like I said, is a long-term plan. It goes up to 2050 and basically looks at trying to achieve energy consumption. These are some of the overall issues. Sorry, there are some parts of my presentation that are not visible. You can see this is the generation of power that is being generated. And you know, in Zambia, we are primarily dependent on hydroelectrical generation of power. And down here, you will see that I have a few hydro percentages of the percentage mix of power that we have in terms of the different sources of power that we have in Zambia. But the middle line here just shows you some of the consumptions, and you can see that the grand total of 100, the biggest consumer is mining, followed by domestic, which implies that our domestic power usage is one that really needs to be looked at and considered for efficiency, because looking at the amount of power that we consume, it's next to the mines, and the mines are a huge production line. And you will see that Going forward, this is the access presentation of power. At national level, we have 53%, 53.6%. The urban setup is got only 80.3%, and the rural area is way down at 34%. So the next one is the RSP strategy. I'm trying to just look at the diversification. So the RSP strategy is basically a plan to try and create diversification in the generation of power, the mix of hydro as well as other sources. So, and the main objective is to drop the 85, where we're standing at 85% of hydropower in 2023. We're expecting by 2050, we will drop the dependence on hydro dominance to 36%. So right now, as we speak, the current tree is at 82%. So we've managed to do a bit of a 3% drop, but that is also not that far. And the strategy is to grow our solar, wind, and biomass, as well as geothermal, to reduce the climate risk. The risk we had in Zambia, which may already be known by many others, is that we suffered a drought, and apparently our generation of power is mostly in the southern province, where if we don't have enough water, then our dam doesn't get enough water. So apparently this is the situation, and because of that, we would like to do a diversification into solar, wind, biomass, as well as geospatial. Then we have also thought we could then do a balancing of how we get this hydropower, because the northern part of Zambia has quite a number of rivers as well as falls that we could use to generate this same hydropower, which is the northern part. Hence, we are looking at the Congo Basin as a source for more power generation as we go through hydro. And of course, resilience measures are climate resilient plant design, ensuring that we do not have the same situation happening again. And the integrated renewable energy up to 20 to 45%. If we can get 45%, and that is the target, we will get 45% of the grid by 2050. And of course, environmental social safeguards in all project planning, because the biggest challenge is when we have situations that affect our ecosystems, our environment, then we are not going to be able to have enough power. And then, of course, we need to understand the impacts that climate change has had on our energy sector. One of them is a reduced generation from hydro. We have also reduced household electricity supplies. You'll note that every Zambian will tell you about load shedding, because everybody in Zambia has experienced it, despite the fact that the northern part of Zambia could still receive quite a substantial amount of rain, every part of the country, because all our power is generated from one source, mainly in the south. And of course, we have had increased consumption of charcoal, which again now weighs heavily on the environment. And then we've also had an increase in solar as part of the country's overall electricity generation mix, along with a rise in solar installations by household, which again, as much as it's an impact, it can also be one of those things, success story that we can talk about, because a lot of households that are able to afford solar have actually gone onto solar as an alternative. And of course, lastly, we have an increased uptake of liquefied petroleum gas, which is now mostly now being understood by a lot of households as one method of ensuring that the household is able to do the cooking and other things that they need through liquefied LPGs. Now, in terms of targets, Zambia has made commitments, and some of the indicators that we expect are increased access to electricity. The baseline in 2017 to 2021, say 6% annual electricity, only 60 connections per year. And this interpreted into 1.4 million people connected. So the target for 2030 is to have at least 12% annual electricity rate connection, which we interpret into 120 on the grid and 3.2 million on grid shared. And maybe the other power usage will be on the mini grid. And the increased access to clean cooking is only looking at 9% as of now, but we have not really envisaged a target that can, sorry, I've moved my line. Increasing share of renewable energy in power generation. Currently, we are generating 3,336 megawatts. By 2030, the target is to be able to generate 9,000 megawatts through the different interventions, such as coming up with new hydro power plants in the northern end, as well as taking some of the power generation off grid into off hydro into solar, wind, and other sources. And the fourth item, which is a target, is to have an amount of private capital mobilization. Currently, we as Zambia, our procurement method and even venture method in terms of activity, even in the energy sector, is to ensure that there's a good number of participation for the private sector. And right now we are looking at 1.6 billion, and we are hoping that by 2030, and the target is that we will have at least 9 billion of investment from the private capital mobilization, which means we would want the private sector to take this as an opportunity and be able to invest in the power generation sector. So let's look at what do we have as Zambia in terms of pipeline projects. Like I said, we are trying to increase the amount of private sector participation. In the public sector, we have about 20 projects, and the private sector, we have about 42 projects. So altogether, that's 62 projects that are in the pipeline. But these projects right now obviously need some investment. And you can see on the right there, I'm trying to just depict the share percentage in terms of the pie, how much of the pie the public sector has and how much the private sector has. And you can see that the private sector has a good share of projects that, if implemented, then would have that participation. So for this, would want to expect that in Q1 of 2025, we have already had 700,000 megawatts of possible projects signed by 2025. So we have had quite an amount of energy movement in that realm. Now, such an ambitious and big implementation would definitely require a framework that is vigorous and is able to actually deliver. And for Zambia's IRP, we have a structure that starts from as high as the presidency, with PDU, the PDU unit, which is a presidential delivery unit. And I've done a few notes on the right that speak to it. The PDU link into presidency alignment with the presidential priorities to ensure that the country is moving with the agenda. And of course, under that, we have a steering committee which is comprised of government ministries, such as ourselves, Ministry of Energy and others, as well as the private sector and CPs. And then below that, we have implementation technical levels. Again, at this level, as a ministry and the ministries are involved at this level, because at the steering committee level, we have our ministerial as well as our PSs. And then, of course, Ministry of Energy act as the secretariat for this particular plan, and this is monitored and reported by the different stakeholders that have. So generally, before I say thank you, this is the landscape that we have in the energy sector, which apparently now requires us to start refocusing on being efficient in how we use our energy and prioritizing what we can be able to do because of this scenario that I've just explained. Unless there are questions, I think my presentation would end here.
Thank you so much, Mr. Zulu, for your presentation. It gives us a very good perspective on the challenges that Zambia is currently facing. And it's also very interesting to see these ambitious targets and the implementation framework that have been planned for Zambia. And now, to hear from the perspective of Mauritius, I will invite Mr. Ziad Tufani from the Energy Efficiency Management Office to present. So, Ziad, the floor is yours.
So, by way of an introduction, I am Mr. Tufani Ziad. I am an engineer at the Energy Efficiency Management Office. So, I'll just give you a brief intro to Mauritius. Mauritius is a small island in the Indian Ocean, and we are approximately 2,000 kilometers southeast of Africa. So, we don't have much of a land. We have approximately 2,040 square kilometers. Our main sector is focused on the tourism sector, financial services, and the manufacturing sector. And it's also important to note that Mauritius is a small island development state. That is, we are very vulnerable to tropical cyclones, torrential rains, rising sea levels, and also rising temperatures. In terms of climate goals, despite we've got an emission of approximately 0.01% of GHG, Mauritius has been very ambitious in its new NDC in 2021. Our target is to achieve 40% of GHG emission, 60% of renewable energy in our electricity mix, phasing out the coal in the electricity mix, and also increasing energy efficiency by 10% by 2030 based on 2019 figures. And all these targets is based on 65% conditional funding and 35% unconditional. And we've made actually throughout the past years, we've made some progress in terms of energy efficiency. Let's take a look about our primary requirements. Mauritius being a small island, we import all of our fossil fuel. For example, here, as you can see, the gasoline, the diesel oil, and the aviation fuel is for the transport sector. The coal, the fuel oil is for the electricity production. LPG for the household sector and the manufacturing sector. And in terms of renewable energy, we've got only approximately 8.2%, with bagasse being the predominant one. So this is in terms of primary energy requirements. Let's take a look now in terms of electricity production. For Mauritius, electricity is produced by the Central Electricity Board and our IPPs. The Central Electricity Board uses heavy fuel oil, which amounts to 48%, and the IPPs use the coal, which amounts to 33.5%. And our renewable energy share is dominantly by bagasse, which amounts to 9.5%, which is mainly from our sugarcane fields during the crop season. And in addition, the photovoltaic, the solar energy, we are slowly increasing our share in terms of PV. And also in terms of hydro, we've got 10 hydropower stations in Mauritius. As I've said, in terms of renewable energy, we've accounted only to 17.6%, and our electricity generated has increased from 2022 to 2023 by 4.7%. That is why there is a need for energy efficiency in Mauritius. In terms of energy demand, there are three columns here in terms of the domestic sector, the commercial sector, the industrial sector. Let's take a look in terms of a consumption of domestic, that is the household sector, which amounts to 36.5%. The commercial sector, the highest percentage share amounts to 37.5%. Again, these two sectors, the household sector and the commercial sector, which is very dominant, which it is why the Energy Efficiency Management Office is focusing on these two main sectors in terms of energy efficiency, and also in the industrial sector and the manufacturing sector, we are focusing to a lesser extent. In terms of peak demand, Mauritius has experienced the hottest January recorded ever in January 2025. But this, we've recorded a peak demand of 567.9 megawatt. Our capacity is approximately about 626 megawatt. There is a constant stress and strain on our grid system, and the demand keeps on increasing. This is due, again, there is the need for energy efficiency in Mauritius. And we'll go in the next slide in terms of the impact of this high demand on our economic sector. That is why now the Energy Efficiency Management Office has been set up in 2021. We are a body under the Ministry of Energy and Public Utilities with the following mission: to lead the country in energy efficiency development and promotion, to facilitate the management of energy efficiency in all sectors, that is from transport, building, industry services, as well as household sector, which you have seen is a very high consumer of electricity. And finally, to foster a culture of energy efficiency for awareness, capacity building, and any other initiatives. Let's take a look at the impact of energy efficiency in Mauritius. The EMO has implemented the minimum energy performance standards for air conditioning. We have made energy audits mandatory for those who surpass a mentioned threshold. So the impact of the energy efficiency measures, we've calculated the energy saving potential from the recommendations of energy audits conducted by our energy auditors. We can save approximately 90,000 megawatt hour per year with a saving of 314 million rupees. That is in terms of economic impact. And also the EMO has launched budget measure in 21 and 22. We've measured the consumption in the public sector. Through awareness, through guidelines, through sensitization campaigns, we've gone through all the public bodies, and we've differentiated figures from 2019 and 2023. As can be seen, we have been able to reduce our electricity consumption and about 2%, as shown in the table here below. This is another figure. As I've told you, we've experienced a peak in this year. So the peak is shown in the red figures. The EMO, the Ministry of Energy, and the CB has launched a massive campaign of energy saving campaign, and we've been able to decrease our peak demand. As you can see, the red one, it is the peak demand that we've recorded this year. But subsequently, through our campaign on the national TV, on the radios, on any other social medias, we've sensitized people through the energy conservation measures, and we've been able to reduce our demand by approximately, if you see, for the 6th March, by 50 megawatt. So it was a good impact on the CB, which reduced the stress on their grid. That's a bit about the economic impact. But in terms of environmental impact, again, we've done a calculation based from the energy saving potential from our energy audits. We can save approximately 80,000 tons of CO2 per year. And our grid emission factor is a Tier 1 calculation, 0.9543, and we are going through a Tier 3, which is in process by another ministry. In terms of social impact, EMO has gone through all different ages, group segments from public primary schools, secondary schools, the working population, and the elderly. There is a real encouragement by the public. They are coming to us to explain, to sensitize them about the impact of energy efficiency, and people are very welcoming to our measures, our proposed energy conservation measures. And it is an ongoing process by the EMO throughout the year to sensitize the whole population about the benefits of energy efficiency. And in terms of our way forward, Mauritius the EMO is working towards the MEPS for refrigerators, for lightings. We're also going to set up a framework for energy performance contracting that will be able to set up a ESCO market. We've got a project with a mitigation action facility, a de-risking facility for energy performance contracting, which I will explain to you tomorrow. We've got a project with a UNEP CCC, a regional roadmap for energy efficiency at Côte d'Or, and also we are working for the energy efficiency building codes. So that is our way forward for the EMO. So to conclude, just a brief motto, that is, let's keep being energy efficient through awareness, action, results, and sharing. So I thank you all for your attention and wish you a good webinar ahead.
Thank you so much, Ziad, for sharing that insightful overview of Mauritius and for highlighting the key priorities and progress that has been made in energy efficiency. And as we can see, the challenges faced by Mauritius and Zambia, they highlight the crucial role of energy efficiency in meeting their specific needs. And having examined these challenges, we will now turn to potential solutions by exploring effective energy efficiency strategies for buildings. And in this next session, we'll review key approaches that can be adopted not only in Mauritius and Zambia, but for other regions as well. So let me quickly share my screen again. So building energy efficiency strategies can be broadly divided into two categories: passive measures and active measures. Together, these approaches help reduce energy consumption, lower operating costs, and enhance occupant comfort. To start with the passive measures, these are design-focused strategies that reduce energy demand without relying on mechanical systems. The goal is to make the building inherently efficient through thoughtful architectural planning. Such strategies include optimizing natural ventilation, maximizing daylight to reduce the need for artificial lighting, and minimizing heat gain to lower cooling needs. Key factors such as building orientation, spatial layout, and the selection of envelope materials such as walls, windows, and roofing materials play a critical role in enhancing energy efficiency through design alone. Active measures, on the other hand, involve technological solutions. They can directly reduce energy consumption through the use of high-efficiency systems. By incorporating energy-efficient lighting, HVAC systems, and appliances, buildings can significantly lower their operational energy use while maintaining comfort and functionality. In this session, we'll briefly explore some of these key strategies, while a more in-depth look at their practical implementation will be covered on day 3 of the e-training program. So I hope you will all join us then as well. To begin with high-performance windows, these are a great way to improve insulation, indoor comfort, and overall energy efficiency. In hot climates, they are especially useful because they can block excess solar heat while still allowing natural light. And these windows are designed to reduce heat transfer, help maintain comfortable indoor temperatures, and also cut down on energy use. They often include multiple panes of glass with insulating gas such as argon in between them, and this boosts their thermal performance. Another important feature is the low emissivity or the low E coating, which is a microscopically thin metallic layer which is applied to the glass. The lower emissivity means the windows can reflect more thermal energy than a standard glass, and this means less heat gets through. In climates where cooling is the main concern, you want glazing that lets in daylight but blocks as much of the sun's infrared heat as possible. Some low E coatings are spectrally selective, meaning they filter out 40 to 70% of solar heat while still allowing plenty of visible light to pass through. To get the most out of high-performance windows, it's a good idea to combine them with external or internal shading devices, such as overhangs that block direct sunlight and further reduce cooling loads. And when incorporating these windows, one of the key considerations is the building orientation itself. Knowing which sides of the building gets the most intense afternoon sun, especially during the summer season, helps you place and select windows more effectively. And when it comes to setting energy efficiency standards for windows, the United States has set up the Energy Star program. It's a government-backed initiative that helps identify products such as windows and doors that meet strict energy performance criteria, which are often tailored to different climatic zones. And in the case of America, they have 4 distinct climatic zones across the country. And you can see that on the map here. For windows to earn the Energy Star label, it must meet certain performance benchmarks, especially in terms of 2 main ratings, which is the U value and the solar heat gain coefficient, or the SHGC. The U value basically tells you how well a window is insulating, while the SHGC tells you how much of the sun's heat can pass through the window. Lower SHGC is better for hot climates because it means less solar heat is entering the building, keeping it cooler inside. The table here shows the threshold for the U value and SHGC value for the southern climatic zone, and this zone mainly has cooling needs, which are more similar to the requirements for buildings in countries such as Zambia and Mauritius. The next passive strategy is natural ventilation. So using natural movement of the air to cool and ventilate indoor spaces. And this approach has several benefits. It not only improves indoor air quality, but also supports occupant health and comfort and reduces the need for mechanical cooling, which means lower energy use and energy savings. To make natural ventilation effective, it is important to consider things like building orientation again and the placement of windows or vents right from the design stage itself. So these decisions help capture and channel the breeze based on local environmental conditions. And a great example of traditional natural ventilation in action comes from the village of Yazd in Iran, which you can see in this picture. They have many buildings that are equipped with such tall structures called wind catchers, and these towers are designed to harness prevailing winds and direct the cool air into the living spaces inside the building below. And this is how they typically work. So the towers have openings that face into the wind, and they capture and funnel it down into the building, and they create a light breeze. These structures also often work alongside water reservoirs beneath them, so the cool air can be cooled down even more, especially in the region's hot and dry climate. And when there is no wind, the wind catchers still function like chimneys. So hot air actually rises and it escapes through the tower, and it draws in cooler air coming from below and creates a steady flow. And this is one of the most brilliant examples of passive cooling that has been used for many, many centuries. The next passive strategy is designing for daylighting. So this means bringing in natural light into the building in a controlled way to reduce the need for artificial lighting and to save energy. The photo on the slide is actually from the office building where my colleagues and I currently work in Copenhagen. It's actually a LEED Platinum certified building, which means the building has demonstrated exceptional performance in areas such as energy efficiency. And what's especially impressive is that even though Copenhagen is known for its cloudy weather most of the year, the building still gets an abundance of natural light. So that's thanks to the large glass rooftop, which spans much of the building and allows daylight to pour into the building. And it reduces the need for electrical lighting during a normal day. And when designing for daylighting, there are several important factors to consider. Externally, things like building orientation, nearby structures, local climate, and surrounding environment can all influence how much natural light a building can capture. Internally, you need to think about the building's function, the layout of the space, how reflective the interior surfaces are, how deep are the rooms, and where the windows are placed. All of these elements work together to make sure natural light is used efficiently, and this enhances both the energy savings as well as quality of the indoor environment. And another effective passive strategy is to reduce a building's cooling demand by using cool roofs. Now, these are designed to reflect more sunlight and absorb less heat than a conventional roof. So, this helps keep the building cooler and reduces the need for air conditioning. This is especially important with materials like concrete, which tend to absorb and retain heat throughout the day, and even after sunset, that stored heat radiates into the building, rising the indoor temperature and increasing discomfort and energy use. In contrast, roofs can dramatically lower surface temperatures. So while traditional roofs may absorb over 90% of the sun's energy, cool roofs can cut that down to less than 50%. The performance of cool roof materials depends on two key properties such as solar reflectance and thermal emittance, and both are rated from the range 0 to 1. The higher these values, the better the roof can stay cool under direct sunlight. And Energy Star, which was mentioned before, also certifies cool roofing products in the US, and they set minimum standards for reflectance and labeling high performance options. A common and cost effective option is reflective roof coating, and they are sometimes called cool roof paints, which reflect a significant portion of the sunlight and limits the heat buildup. And for even better results, cool roofs can be combined with proper insulation and green roof systems or nature-based solutions to further enhance indoor comfort and energy efficiency. And now to learn a bit more about such nature-based solutions that can support the energy efficiency in buildings, I would like to invite my colleague Talat to please present on the topic. So Talat, the floor is yours.
And I think it is good that background has been laid down for me to talk on nature-based solutions. Uh, we are actively working on in three countries now: India, Zambia, and Mauritius. Um, as in Zambia and Mauritius, we are moving ahead with the projects. We are identifying what to do, where to do. But in India, we have advanced a lot. So what I'll be presenting is from uh, the case in India. So I guess the background has been laid down. So the need for making buildings more energy efficient, why we need to cut down on energy, stress on the fossil fuel because of energy, and also what type of solutions are possible. And Tripti said that there are two types of solutions possible. One is what you could do within the building itself and within the building's envelope, like trying to have more efficient lighting, more efficient equipments, etc. And nature-based solutions are part of the passive solutions that we can have, as what Tripti said, wherein we try to reduce the actual demand for energy. So when we reduce the actual demand for energy, the energy consumption automatically reduces. And what I'll present is some of the findings that we got from the case for Ahmedabad. So basically, the biggest challenge in the context where we have implemented this solution um, is an extreme heat situation where even if the ambient temperature is slightly low, the field temperature is much higher for most of the days in the year. It is around 40, in the range above 40 degrees, which makes living quite comfortable, and need for energy within the buildings quite high. The uh, what has led to it is extreme increase in the built-up area. 124 square kilometers of built-up was added in the last 10 years, which is related to loss of agriculture and green spaces, which have been consumed to build spaces. Uh, a side effect is increased flooding incidences since 2017, mainly local area flooding, which happens because of excessive rainfalls. But this also gives us a lot of opportunity because there are a lot of residential buildings around where nothing has been done, and also commercial buildings where nothing has been done yet. So it is an opportunity for us to convert these buildings uh, to solutions which are close to the nature. So basically, when we talk about nature-based solutions, our understanding is trying to go back to what nature was and how things were done. And couple of things that Tripti talked earlier was the example from Iran, where passive cooling was done. So, but even in Ahmedabad, like if you go and see the old city houses, we already had all these kinds of passive cooling mechanisms wherein the air was channeled through tanks, and there was also holding spaces for waters to avoid flooding, etc. So basically, like some of the solutions were already mentioned by Tripti in our presentation. So what we look at when we look at nature-based solutions is we're looking at solutions which are within the building envelope, like cool roofs. So cool roofs was also mentioned by Tripti in her presentation. One thing that she showed was people painting the roof white to increase the reflectance. But other things that we have been doing in very extreme heat climate for a very long time is also to increase the thickness of the roof so that the percolation of heat is less, and also to use to create air vents within the roof. So so the type of concrete that you use, and also maybe blend some natural elements within the roofing before the top tiling and the roof, so that there is a cushion for the heat to be absorbed within the roof. Other obvious solutions are green roofs and rooftop farming. Most of the roofs in climate like Ahmedabad and maybe Zambia and in Mauritius are flat roofs, which provide a lot of opportunity for green roof farming and also have green roofs. It can also be done on sloping roofs, but the opportunity on flat roofs is much higher because you could do more vegetation there. On the vertical surfaces, you could have vertical greening and vertical facades. So you could have this the greens that grow vertically, and calipers also growing on walls and create a green facade. What can be done outside the building is in terms of design strategies. So the building morphology, so the way buildings are organized, way buildings are oriented. So it's like the example that was given again by Tripti of having the sunroofs. Also, so in the college that I studied in India, the School of Architecture, we had these north lights. So we reduced the need for having lights during the daytime. So there was no direct sunlight, but there was passive sunlight coming into the system. So sometimes in climate, very hot climates, you really don't want the direct sunlight to come into your rooms. Unlike Denmark, so in Denmark we would want direct sunlights coming in, but uh, in climates like India, we want passive light to come in. So northern lights help quite a lot. Enhanced sky view factor. Sky view factor is very important because uh, the roofs also have to breathe. So the if the heat that has been absorbed during the day has to be dissipated during the night. So the more sky view that the roofs have, and the faster is the cooling, and lesser is the heating demand during the night time, or cooling demand during the night time. Uh, Strategic plot setbacks are also important because, like if we see in the old traditional way, so way the things were naturally done in our cities was to have setbacks within the plots, so that the shading was good and the natural shading would reduce the need for heating. There are other solutions which are building adjacent, like permeable pavements, which uh, help you to first, it allows for pavement, but also when the times of flooding, etc., it allows the water to seep down and reduces the need for flooding. So this is again going close to the nature, because in old days we never had pavement, so there was the soil and which allowed water to seep in. So it helps augment the groundwater, and better groundwater also leads to lesser energy requirement for water because most of the water is pumped from the ground. So lower the groundwater level, higher is the pumping requirement. biospheres, rain gardens, and green corridors. So basically, like most of the CO2 emission also comes through transport, but then transport corridors could also provide spaces where trees can come in and help with reduction, help with the green cover. So it's basically trying to get the green cover that was lost when we transferred from agricultural land to built up land by getting these initiatives. Next slide, Aris. So basically, like there is a significant impact. So just by having cool roofs, we can reduce up to 4.6 degrees in temperature. So just the top-down cooling by having cool roofs itself is quite a relief. And basically, it is white ceramic tiles and reflective paints, like what Tripti said, but also using, for example, earthen pots within construction of roofs. Green roofs again. So if you have cool green roofs, the ambient temperature reduction is about 2.4 degrees centigrade. Basically, it is rooftop farming, having trees on the roof, but not large trees. So large trees, if you have larger trees, they would not allow the roofs to breathe. But like shrubs, etc., which allow the roofs to breathe and dissipate also the temperature that comes out. Vertical greening is quite efficient. It also reduces the temperature by 4.1 degrees because it doesn't allow the walls to heat up, etc. And permeable pavements also lead to reduction of peak hour temperature because other pavements are more reflective, etc. So permeable pavements are much better in that sense. And in addition to the reducing the temperature for the buildings and allowing for less cooling in the building, there are additional benefits like stormwater management, etc. Because if we do all this, take all these measures, and the runoff is reduced significantly. And if the runoff is reduced, the local area flooding is also reduced. Because most of us would realize that these are the main problems within the cities where we live. Next slide, Arish. So basically, then how do we fund all of this is also an issue. So in India, what we did was we took up, so the way the urban planning is done or is implemented is through a larger development plan, and in local areas through a town planning scheme. So a town planning scheme is about an hectare of an area, a square kilometer of an area. And we looked at that, we looked at the blue and the green spaces within this uh, square kilometer of an area. And we looked at opportunities, how things can be done. And we also did a cost estimation of implementing the uh, uh, blue and green infrastructure solutions and also solutions for the gray within the buildings. Yeah. We looked at what type of financial structures could be done, but mainly the costing was the most important part. And then where the money is going to come from. That was the most important part within this. Next slide, Arish. So the important part is also like some of the text is not visible, but also to try to get the key players within the country who are going to help implement the solutions. So one is like, so basic thing is, even if we look at our own cities, we see the areas which are more green, which have uh, better gardens, which have more green spaces, where buildings are also more green around them. The real estate price there is much higher. So there is also a land value capture possibility there. But these are not tangible benefits. So initially, like for the city to realize this and also to lead to those tangible benefits, we need to have some sort of a mechanism in place. We need to get the stakeholders in, and so some upfront investment will have to come from somewhere, or will have to be generated either by the countries themselves or through some climate resources. and then mechanisms or an SP will have to be created so that such things can get implemented within the city. Next slide. So we did a cost estimation. Actually, so generally when people talk about NBS, for example, so they club it with the cost of gray solutions. But if we remove the cost of gray solutions, um, the cost estimate was about 8.6 crore Indian rupees, so which is roughly around $1 million US. So, and we are talking about a solution, NBS solutions within a square kilometer of an area. So where the TP schemes have been implemented, so what we went and looked back is how our TP scheme and how urban development is funded. So we already fund, for example, for water supply, for sewerage, for roads, etc., and cost of which is much higher. So even if we look at here, so if we take out the cost of grey infrastructure, which is 60, which is about 8 to 10 times of NBS solutions. So putting in NBS solutions is just about 8 to 10% increase. And way urbanization happens and way rural land is converted into urban land is by taking out part of the rural land and allowing it for road, etc. in Indian conditions. So what we said was that it is only, and some of the land is then reserved from that for sale, which funds the other infrastructure uh, costs. So if we increase that reserve land by about, it's just one plot of about 100 square meters, yeah, that will fund the entire NBS solutions. So if the cities are innovative in the way they do urban development and how they fund urban development, these solutions are not very difficult to implement. Currently, what happens is that some of the big companies under the social responsibility have adopted gardens, etc. But that is not a very sustainable solution. Sustainable solution would be when the development is integrated within the way other things are developed, and this is also looked at other infrastructure, for example, like roads, and then it will be like integrated within the uh, development stream of the cities, and then they would be part of it. And that's it. Thank you so much.
Thank you so much, Talat, for providing those valuable insights on various nature-based solution strategies, and most importantly, also highlighting different cost considerations, and also trying to explore some ways to implement and finance them. And now it's time to take a look at active measures for energy efficiency, and starting with one of the most widely adopted and well-known solutions, which is LED lighting. I think many countries began phasing out incandescent bulbs over a decade ago, and we are now seeing a shift away from fluorescent lighting as well. And this makes LED the dominant lighting technology in many markets. In fact, around 50% of global residential lighting sales are now completely relying on LED technology. LEDs are incredibly efficient, we all know that, and they use up to 75% less energy and last 10 to 25 times longer than traditional incandescent bulbs. And simply replacing older lighting with LEDs can significantly reduce the energy use of a building. And especially when you pair LEDs with smart controls such as occupancy sensors or daylight sensors in large offices and commercial buildings, the savings can be even greater. And they ensure that the lights are only on when it is needed. When it comes to appliances and equipment, two key policy tools often work hand in hand to boost energy efficiency, which are the minimum energy performance standards or MEPS and energy labeling. MEPS often set the minimum efficiency level a product must meet in order to be legally sold or imported. And this ensures that the least efficient models are removed from the market. Energy labeling, on the other hand, helps consumers make informed choices by highlighting the products that go beyond the minimum threshold, and they encourage the purchase of more efficient models. The figure on the slide, it shows an example of the energy label from Malaysia, and they're typically found on household appliances such as refrigerators, air conditioners, washing machines, etc. And these labels are designed to give consumers clear and comparable information about how much energy a product uses. And one of the most important details shown in this label is the annual energy consumption, which is measured in kilowatt hours. And this value is based on standardized testing procedures, which are defined by the government, and also allows consumers to compare energy use across similar models. And most labels use like a star system, where more stars indicate higher efficiency, and they're usually from 1 to 5. Another useful approach is to pair high-efficiency appliances with smart controls that help minimize standby power as well. So this further reduces energy waste. One common concern is that energy-efficient appliances often come with higher upfront cost. However, when you look at the total life cycle cost of the equipment, including the savings on energy bills over time, these appliances almost always result in significant long-term savings. And just a reminder, we'll be exploring these policy tools in more detail tomorrow, with a special focus on Ghana's experience and lessons learned in implementing such regulations. So be sure to join us tomorrow as well. And one of the major contributors to a building's energy use is the cooling demand. And this can account for a large portion of the annual consumption, especially in warmer climates. That's why designing and optimizing the heating, ventilation, and air conditioning, or HVAC systems, is such a critical strategy. This becomes even more important when retrofitting older buildings, where outdated systems often consume excessive energy. And upgrading these systems can lead to substantial improvements in both efficiency and comfort. To dive deeper into such strategies for HVAC systems, I'd like to invite my colleague, Ms. Amira Mudho, to take us through the next part of the session. So, Amira, the floor is yours.
Hello, thank you, Tripti, for the introduction. Hello, everyone. I will be presenting today on energy efficient HVAC to a system. So I will begin with a cooling part of HVAC system, going through the different type of AC available. But before starting on that one, I will like to explain about one part of the AC system called the compressor. You don't see it, but it does most of the work. I like to think of it as a person who's doing all the running behind the scenes, like the heart of the system. Its job is to pump refrigerant through the system and help the AC take the heat out of the room. Now, here's the important part. Turning the compressor on takes a lot of effort, kind of like waking up early on a Monday morning and dragging yourself to work. It takes that extra push to get going, but once you're up and moving, keeping the momentum is a lot more easier. The same goes for the compressor. It uses much less energy when it keeps going, even slowly, than when it has to keep starting. Like I was saying, why it is important to know about the important is because in inverter AC, the compressor run at full speed and then it stop completely. Just like Usain Bolt, it runs super fast and then it stop. The compressor start again when the room gets warm, then stop again when it's cool. And this on and off make it use a lot of energy. Non-inverter AC were traditionally used and are still very much on the market due to the lower capital costs compared to other alternatives. It comes in two types, one being window type AC, which is one component attached to your house, or it comes in a split AC as well. That is, you have an indoor unit and an outdoor unit. Now coming to an inverter AC, here the compressor keeps running at a steady speed. The compressor never completely slows down, stops. It slows down when the room is cool and speed up a little when more cooling is needed. Just smooth and steady, similar to a marathon runner. It uses less energy and that keeps the room more comfortable. Inverter AC are typically found in split ACs, which are basically having one outdoor unit and one or more indoor units. The indoor unit can have different temperatures in different rooms, and they are usually found in houses or small offices. Now that we understand how the compressors work and what is an inverter AC, let's talk about something a bit more advanced, a system called VRF, which stands for Variable Refrigerant Flow. It uses inverter-driven compression, like this in the split AC unit that I just explained. One main difference with multi-split unit AC is that VRF uses dedicated valves at every indoor unit to deliver exactly the refrigerant needed only to room actively looking for cooling, and this makes it much more energy efficient than multi-split unit. What makes some VRF system, not the standard one, even more different is that one VRF system can serve multiple indoor units, is each with independent cooling or heating need. To note that standard multi-split ACs cannot provide both heating and cooling at the same time. But VRF precisely control how every room gets exactly the cooling or heating it requires, and its typical usage is large applications like shopping malls. The benefit does not stop there, as this system allows for heat recovery. To sum up, heat recovery means if a VRF system fed two rooms and one wanted to be heated but the other cool, it could take the heat from the cool room and use it to heat the next room, allowing for greater energy efficiency. And this is another reason it has become so big in the commercial space. There are other AC systems, but for this session, I focus on these because they highlight the basic of energy efficiency and comfort for both residential and commercial usage. Now let's move on to heat pump. For Mauritius, space heating is not really a requirement for our climate, but hot water is pretty much used around the island for domestic purposes as well in our most popular industry, the hotel industry, among other industries. And so I believe heating does have some relevance, and that's why I'm going to talk about heat pump. A heat pump has a main component as an air conditioning systems, things like the compressors that I have already gone through. But what makes it is special is that it can reverse its action. That means a standard heat pump can provide either cooling or heating depending on what you need. When it's set to heating mode, it collects heat from outside sources like from the air, the ground, and even waste heat from industrial processes and transfer it inside. It doesn't generate heat by burning fuel. It simply moves heat, which make it much more efficient. And that brings us to something called COP, or coefficient of performance. COP is a way to measure how efficient a system is. A gas boiler, for example, has a COP of about 0.85, 0.9, meaning that for every 1 unit of energy it uses, you get about 0.85 unit of heat. But a heat pump, because it's just moving heat rather than creating it, can have a COP of 3 or even 4. So for every unit of electricity it uses, you get 3 to 4 units of heat. In warm climate countries like Mauritius and Zambia, most heat pumps can achieve a COP significantly greater than 2. And I can't give an exact number because the COP depends on the climate and the type of heat pump being used. But in general, they still outperform traditional system in terms of energy efficiency. In simple terms, heat pump gives you more heat for the same amount of energy. They're one of the great tool available for efficient and sustainable heating. And as you can see from this diagram, it has widespread usage from domestic to industrial to district heating. Lastly, I would just mention some of the key steps to have an energy efficient HVAC system. One is to have a properly sized system. There's a lot of DIY on the net, some of them good, but if you don't have the time and money to go through the trial and error or try reading one engineering textbook, then it's better to have a professional do a proper sizing. This will ensure a properly designed system that will provide better comfort as well as have a lower running cost in the long run. Secondly, while it might be a bit more of an investment for homeowners, a building energy management system or BEMS is a smart upgrade worth considering. It uses sensor to monitor things like temperature, air quality, and room occupancy, and then automatically adjust your heating, cooling, and lighting accordingly. Due to its zoning capability, it can control each area of your home separately, so energy isn't wasted where it's not needed. The result: better comfort, lower energy bill, and a more sustainable space. And now the last part is, I believe, the easiest. It's to have regular maintenance of your system. And with this, I will thank you for listening to me, and I will leave the floor to the next panelist.
Thank you, Amira, for the insightful overview of the HVAC systems and the strategies to improve their efficiency. Now, I would like to move on to the next active measure, which is the integration of renewable energy. Aris, could you please allow me to share screen? So, although renewable energy isn't strictly classified as an energy efficiency measure, incorporating technologies like solar PV or more modern building integrated photovoltaics to generate electricity, as well as solar thermal systems for hot water, plays a crucial role in reducing the building's reliance on non-renewable energy sources. So when planning to integrate such systems into the building, several factors should be considered, such as the orientation, availability of roof or the facade area, local solar potential, initial investment costs and payback period, and also consider opportunities to pair solar systems with storage systems such as batteries for added reliance. And all of these elements help determine the feasibility and the long-term benefits of renewable energy integration into building design and retrofits. There is also energy management systems that Amira briefly mentioned. So pairing all these active measures with an energy management system, especially for large and complex buildings such as offices, also leads to reduction in the overall energy use by boosting the performance of the building. So that concludes the first round of presentations on the key energy efficiency strategies for buildings. I hope this was a good refresher for the professionals who are attending this webinar, and maybe it brought to your attention some strategies that were previously overlooked. Now it's time for the final presentation of the day. Ms. Lenore from IFC will be presenting the EDGE certification for buildings and also some case studies from Africa. So Lenore, the floor is yours.
So thank you. Just introducing the EDGE certification system and how we've been expanding across Africa. EDGE also helps to access green finance, and that's also one of the linkages I'll be making in the presentation this morning. So IFC's got an holistic approach to addressing climate change, mitigation and adaptation in the built environment. We have the EDGE Green Building Certification System, which is on the mitigation side, and this was launched globally in 2013 and in 2015 in Africa. So this year is our 10th year and we will be celebrating that also in Africa. We also have the Building Resilience Index, and I'll go into more detail on Thursday about that. That's on the adaptation side. And we also have the Green Cities Apex tool, which is for green investment planning for cities, and that was launched in 2022. That's also on the mitigation side. Just to give you an overview of how we've grown the program across the continent and globally. We've got 4 major areas that we use to approach our green building market transformation program. We have public policy, where we work with regulators around green building incentives, and that's something I think you'll be covering tomorrow's presentations. We also have linkages to green finance. We help developers to be able to create green building assets that can then be linked to green building finance. We also have had different investments that have helped to catalyze the green building market in different countries. And we have a specific program that has been offering concessional finance to banks for them to create green products that can then catalyze the green building market in various countries around the world and in 8 countries across Africa. So far globally, we've had more than 100 million square meters certified. And then on the investment side, we've had close to $16 billion investment and green building investment mobilization that's from other investors has been $5 billion. And across Africa, we've had about $1 billion invested by IFC through concessional finance as well. In terms of partnerships, we've helped to empower many green building professionals to become edge experts that can encourage and advise clients on the green building design. And we have over 2,400 of those edge experts globally and over 76 edge champions. An edge champion is a client that has committed their portfolio to green certification. And Edge is used in over 200 countries, and we have over 86,000 users globally. So why did we create the Edge Green Building Standard? What we realized is that only a small number of projects in the emerging markets were going green, and that there was a need for a simple, quick, and affordable system. We especially saw that in the housing sector, there was a great need for a certification system that could be used in the mass market and be rolled out even in affordable housing or in social housing. So Edge was developed to have a matrix-driven, scalable, voluntary standard that is to bring together market players with a proven case for green building and to reward innovative design. So Edge makes it easy to design and certify resource-efficient and zero-carbon buildings. It's affordable, the design software is free, it's a web-based application that anyone can use directly off our website. And it also has calculators that allow you to make decisions around which energy efficient, water efficient, or materials efficient options will be most cost effective. So it's got an inbuilt tool that allows you to make the business case for why you are choosing those particular options and how that can benefit the project. And also the certification process is streamlined and simplified and is at a lower cost and fees from other traditional options. It's measurable. It's a simple standard based on quantified energy, water, and material savings. And it also provides impact reporting. Many of our clients are needing to report on the impact of the projects, and this helps them to to have the quantifiable, to have those quantified, what those energy savings, water savings, or material savings will be, what the tons of CO2 emissions saved would be, and so on. It is also internationally recognized for green finance, and that makes it fast and easy to verify the resource efficiency of a project. And this is also some statistics around green building certification, how we've grown the project. And you'll see we save over 2.4 million tons of CO2 per year. And you'll see all the countries across Africa that are using EDGE and where we've got certification so far. And how we've grown across the continent from 2016. That's when we had the first certifications. We had the preliminary certification in 2015 and then grew on from there. We've certified so far over 11 million square meters. From the start of the year, it just was 10 million, so it was 10 million in 10 years, and now we've reached over 11 million square meters. The vast majority of that has been in South Africa with over 6.7 million square meters, and the next biggest country is Kenya, that just reached 1 million square meters, and then other countries in lower certification numbers. How are we different from some of the other certification systems? There's the inbuilt cost calculator that helps you to just decide the best green options and estimate the incremental cost for going green. We found for some of our clients that can be less than 2%, although we often say there's a range between 3 and 5%, but for some clients they've managed to bring it down to even less than 1%. There's a focus on resource efficiency. There's also bioclimatic modeling, so it's EDGE location specific. That means, for example, if you have a project in Mauritius or in Zambia, it's using the local climatic conditions for the project, and even though it's a global standard, it does take into account those local conditions. It can also be used to access green finance, such as issuing a green bond. And I'll give some examples of how we've helped clients to issue, to have the use of proceeds approved through EDGE certification, as well as clients who have a REIT, how we've helped them to access green finance, and also helps to future-proof assets and streamline ESG reporting. It's recognized across a number of international finance standards, such as the International Capital Markets Association, GRESB, Climate Bonds Initiative, Carbon Disclosure Project, EU Taxonomy, and Global Reporting Initiative. EDGE can be used across a variety of typologies, including homes, hospitals, industry, such as warehouses or light industrial buildings, offices, retail, warehouses, hospitality, and education. There are 3 different levels that you can certify a building at. The first level is 20% more efficient in energy, water, and embodied carbon in the materials. Level 2 is EDGE Advanced, which is 40% or more on-site energy savings. And then if you push that through to at 100%, you can reach zero carbon, which is 100% renewables or purchased carbon offsets. So it compares the green building to your locally relevant conventional building standard. So whatever that standard is within the country that you're operating, that's what it will compare it to, whatever the national building code is. So within the free software, there are calculations that are being done. It will give you the energy, energy, water, and material savings. As you'll see there, the 3 different options at the top. And that helps you to see how close you are to certifications. It also gives you the reduction in utility costs. So what this helps is if you are trying to motivate for example, a home buyer, that if they buy this home, then they're going to get a certain level of savings, then this inbuilt calculator helps you to estimate what those savings will be per month. It also helps you to look at what the payback period is. So if you are investing in those changes to make the building comply with the standard, there is an upfront incremental cost, but that can be recouped against the savings in energy and water in the utility bill savings. So what we've seen with some clients is that they have, we have a client that compared the existing home developments that were not certified and did not have the energy efficiency with one that did and got EDGE certified. And they found that they could save clients up to 1 month's rental over a 12-month period. And this is in the affordable housing sector. So they've actually used that as a way to be able to advertise to potential renters that if you rent this building, which is a green building, you will actually save on your energy and water bills. And that has actually become a selling point for them, up to 1 month's rental, which is significant in the affordable housing sector. There's also the operational CO2 savings that it shows in tons of CO2 per year, and also the savings in terms of carbon emissions. So it also helps with carbon tracking. So here are just some case studies. We have a whole library of case studies that you can see on our website. These are some examples from different certifications we've had across Africa. We've reached EDGE Advanced for the Cosmos Angre, the Nine Palms in South Africa, Sterling Towers office in Nigeria. That was a retrofit where they racked the whole building with PV. So the whole building is using solar, basically. And then we had the Grand Egyptian Museum, which is which was the EDGE project of the year last year. It's an amazing building. It's a mixed-use building that was certified, and of course, quite an iconic building next to the pyramids of Giza. And then we have an EDGE Advanced in South Africa. It's a retail project. There's also an office in Kenya, the Children's Investment Fund, industrial in Kenya, at the River EPZ, and also some affordable housing apartments in South Africa. So just to give you some examples of how we've helped clients to access green finance. In Kenya, Acorn issued the first green bond, and they did this by certifying a portfolio of student housing accommodation. They benefited from the government tax incentive that made this interest exempt. So it's a green bond tax exemption. And they used EDGE in the certification process that aligned with the International Capital Markets Association standard. They used the proceeds for about 7,000 beds that were EDGE certified. In Côte d'Ivoire, we helped the client to refinance an existing mall. It was a shopping mall that they did retrofits on, and they had an existing loan with the bank. They issued a green bond and then were able to improve the rate that they got through the green bond issuance. That was priced at 150 basis points lower than the 9% interest rate that they were getting from the existing bank loan. And in that case, you'll see that they got predicted savings of 29% on energy, water, and embodied energy in the materials. And they used fairly simple measures such as reflective exterior paint and insulation for the roof and external walls. And they also used aerators or auto shut-off faucets and water-efficient water closets and urinals and kitchen faucets. In South Africa, this is a client that received a $25 million investment from IFC that actually catalyzed the green building program in South Africa. It started in South Africa and then spread across to various other countries across Africa. They have certified 13,000 units, and they've used fairly simple features, including passive design. And what they saw was initially the incremental cost of going green was between 2 and 6% in 2017. But by 2020, they were able to reduce that to less than 1% per unit. And this is the client that has been using the sales pitch of saving up to 1 month's rental in the affordable housing market of between 5,500 and 7,500 Rand per month. And these are examples of different projects that they've certified there. This is another client that has they committed their whole portfolio to green certification, so they're an EDGE champion. They initially committed 13,000 units for certification in 2019, and then another 12,000 in 2021. And because they had this very large portfolio, one of the banks stepped up and decided to create the first green mortgage product in South Africa, and that was Absa Bank. And subsequent, they were offering a lower mortgage rate to home buyers if they bought a green home. And because of that, they catalyzed the other banks to also create similar products. So what this shows is that when the buildings are certified, it gives the financiers some certainty that they can say that this building is actually green, and then whoever has developed that can then benefit from accessing the green finance and the green investments. And this is the last example from here. This is an example of where IFC invested in, did a green bond with Nedbank, which is one of the big banks in South Africa, and they then financed one of the clients. This is Attack. They did the biggest mall. It's a sustainable retail mall of over 480,000 square meters, and this was using concessional finance. They have the savings from the interventions was enough energy to power 27,800 homes, and CO2 emissions savings of over 2,000 passenger cars annually. You'll see there that the predictive savings are over 53% on energy and 28% on water and 100% embodied energy in the materials. So thank you. I'll stop there, and if there are any questions.
Thanks a lot, Lenore, for your insightful presentation. I think green building certifications are indeed an important piece of the puzzle, and it was also great to see the progress that has been made in Africa so far. So thanks again, Lenore. And now, before we turn to the panel discussion, I also wanted to mention that the webinar series is being recorded, and all of the presentations and the material that we shared today will be available on our website's knowledge management system in a few days, along with the recording as well. And now let's move on to the panel discussion. I would like to request all our panelists to kindly turn on your microphones and cameras. While you try to fix your setup, I would like to welcome you to this session. Mr. Umeshwar is the Director of the Energy Efficiency Management Office in Mauritius, and he will be participating in this panel discussion on the behalf of EMO. So we have been receiving some interesting questions. And I would like to start with the questions for the panelists with some experience with international collaborations between government and the private sector and international partners. What are the most urgently needed priorities to accelerate adoption of building efficiency strategies? So, Mr. Zulu, would you like to begin?
Gladly. Well, for us in Zambia, and I think everywhere else, what would be important for us to access energy efficiency initiatives more vigorously, we would need a lot of public-private partnerships to take place, because you realize that whilst government's mandate is to deliver to the masses, we also have the responsibility of growing the economy, and part of growing the economy is partnering with the private sector. So a lot of collaboration with the private sector would need to take place, and that's one of the things that we're trying to do in Zambia in terms of looking at our energy crisis and energy needs. There's a lot of push to have the private sector take their role in the whole thing. But then again, we also need to also get support wherever we can, whether in capacity building as well as financial, to actually execute some of the projects that need to be executed, because the initial investment is quite heavy. I think that's all I can say for now on that biggest barrier. I guess finance is the biggest barrier. So we can either tap from the private sector, or indeed do a collaborative move with financial givers such as GCF and others that are able to give money towards such initiatives.
Thanks, Mr. Zulu. And now turning to Mr. Umeshwar, I think we can see you now. Would you like to follow up from the perspective of Mauritius as well?
In fact, in Mauritius, we have another constraint concerning the adoption of energy efficient buildings. And Mauritius is a cyclone-prone region. So historically, we have been at the visit of severe cyclones in the past, in 1970. And from that point on, people adopted construction methods which were meant to last in time, because they had been traumatized by the passage of the cyclone. And this practice has been pursued over time, and it's very difficult to influence people to adopt new methods of construction. I think, as in other countries, one in a lifetime investment for most people. So unless we have innovative methods of constructing buildings which are resistant to cyclone, and influencing people to adopt these measures, I think it's going to be difficult for implementing energy efficient buildings unless we have this confirmation that these buildings have proven to withstand such conditions. And also in Mauritius, we have a prevailing situation where we don't have enforceable building codes. We have a draft, but we need to implement this to make this become enforceable, because this is the basis from where we can build upon and set out standards for the performance. Unless we have these codes enforced, it's going to be something voluntary, and it's going to be those organizations who can afford to implement these measures who are going to embark. And we have private sector organizations succeeded in implementing energy efficient buildings. But the comment you receive from the public official is that it's very costly. So for government to move ahead to where it's facing a dilemma of providing low-cost housing to its citizens, unless you prove that energy efficiency and low cost go hand in hand, it's going to be difficult for the time being. So we need to have more discussions and partnerships with the private sector, and also with companies who wish to put forward energy efficient technologies which are relevant to the regional requirements for Mauritius.
Thanks, Mr. Umeshwar. I think you made some very interesting points, especially regarding the building energy efficiency codes. I know Mr. Zulu mentioned that Zambia has a code, but now is also in the process of renewing it. So it will indeed be an important policy that can be utilized to improve energy efficiency of buildings. And this is something that we can also discuss in more detail tomorrow. And now, Lenore, I wanted to see if IFC has any views, because now we heard the perspective from the government side, but now you as a facilitator for green finance for building energy efficiency, could you provide some more points from your side, please?
Yes, sure. So from our side, we've been working with regulators in different countries and various governments, and what we found that also helps to accelerate the process is if there are government incentives. In some countries we've had government non-fiscal government incentives, such as height bonus in Peru, where if developers were to certify their buildings, then they get an additional floor that they can build. Sorry. Apologies, there's some construction happening. And we've also found that when we can also do a capacity building both in the private and the public sector to help to increase the awareness that it's not as difficult to go green as people might think, that in fact many measures and design many architects are already designing for green, and sometimes they just need to tweak things here and there in order to be able to meet a green building standard. The other things that we are also doing, and that I mentioned earlier, is that providing concessional finance through the private sector for developers to be able to develop green. That we've also found has helped to open up the markets. It's not always easy to access finance, as Mr. Zulu said, and so having these kinds of concessional finance facilities available through banks that then create the green financial products, we found is also helped to open up the markets.
Great. I think that's quite important. You can talk about the strategies and build capacities, but unless there is financing, you cannot really achieve the momentum that is required. So thanks for your perspective, Lenore. Now we have a bit of a technical question for the HVAC systems for Ms. Amira. So what are the low-hanging fruits when it comes to retrofitting existing HVAC systems for energy efficiency in your region?
Switching to heat pump for water heating is a major opportunity. While the upfront cost, as mentioned by Omeshwar Sitohol, is higher, with targeted financial and policy support, this can definitely happen. And second, prioritizing high efficiency rated HVAC unit at the point of purchase is essential when retrofitting. Unfortunately, users in Mauritius often focus on upfront costs and brand rather than efficiency. So those two.
Great. Thanks, Amira. Thanks for your answer. The next question is again for the representatives from Zambia and Mauritius. So are local architects and builders adequately trained in energy efficient building design? And if not, what are the current capacity gaps that need to be addressed?
I was just saying that primarily the training that we undergo as architects does equip us to do a good level of designing for green buildings as well as other things. However, it is an issue of sometimes when the client requires you to do a building, you may not effectively and actively always consider the green aspect as a requirement. But as it is now with the current climatic conditions, changes that we've had in climate and the diverse effects that climate has on our built environments, we somehow have to just tweak our designs to the point that we have to make sure that it is not a business as usual kind of design for us to make, but we need to do deliberate design efforts to try and make sure that whatever design we make will answer to the different climate conditions, as well as still give a comfortable and amicable environment for the people that we design for. And in terms of what is lacking, what capacity need to be built, I guess it's reminders, webinars such as this one, which take us back to some of the basics that we may already know, but then we need to be reminded, and awareness of what actually is happening around us in terms of climate changes, as well as issues that have to do with the environment within we are in. But capacity building is one of them. It could be in-service capacity building, as well as curricular change in some of the training that is going for those that are coming behind us or that are currently being trained, so that there's deliberate effort to incorporate energy efficiency as a component. Because if you're going to do a green building, then you must understand that energy efficiency is at the core of a green building. So you can't have a green building, even when we talk about green architecture, we can't have green architecture without being efficient in how the energy is going to be consumed. So I guess that's something that as architects we need to embrace and make sure that it is our core foundation. And sometimes people might say, I don't prescribe to this and that, but as architects, it has to just cut across the board. We all have to be architects that think green and design green.
Thanks, Mr. Zulu. Mr. Umeshwar, would you like to take over?
Yes, I would like to comment on this because in Mauritius, there has been a number of training which have been done in the past. These have been done during the development of the draft building code. And architects are fully aware of the need to move towards greener buildings. But as I mentioned, unless we have the codes in place, the demand for such designs will remain dormant, and we'll go on trying the true and tried designs which have worked out. And also, there are a number of institutions which can provide training in Mauritius, but once the codes are in place, we'll see the need and the demand for training, specifically for energy efficient buildings. And thereon, we can set up committees involving the training institutions, the tertiary institutions, to further fine-tune what are the needs currently, because the trainings which we had, we did from quite a few years back. And also, in terms of the professional institutions, registration bodies, I think they also should form part of these committees, so that we can have a cross-cutting view of what is needed. Because training is available, I think, easily now because we have this connected society. And I think we first and foremost, we need to have the codes in place. This is going to be the main element which will catalyze this energy efficiency in buildings in Mauritius.
Thank you for your answer. I hope that some of the capacity gaps that was mentioned is being addressed with this e-training program, especially on day 3, where we will be diving into the more practical implementation of such strategies. And we hope through this project we continue to support any other gaps that Mauritius and Zambia or any other countries might have with respect to accelerating energy efficiency adoption for buildings. The next question is for Eleanor. We are getting a lot of questions regarding EDGE certification. So a lot of our participants want to know, how do you get EDGE certified? I think as an engineer or a designer and not for the building. And what does it cost? And is this program free?
Thanks for that. We have a program that trains green design professionals to become edge experts, that we call them. They are able to guide a client through the edge certification process. That training is usually, it's usually 2 half days or 1 full day. So it's just a 1-day training, but then there is a subsequent exam, and we usually suggest that some studying is required before, in order to pass the exam, because it is quite technical. So then that equips the green building design professional to be able to understand some of the inner workings of the edge application, the web-based application, some of the calculations it does behind the scenes. So it helps to understand some of the calculations that are being done behind the scenes in the app, but it also shows them what sort of documentation is required in order to demonstrate that the project is meeting the standard. So we have a number of trainers that are available to offer this kind of training. The training we also have some trainers specifically in Mauritius, and not yet in Zambia, but definitely in Mauritius. So that's possible, but they can also take online training and face training. If they go to edgebuildings.com, then they will and look along the edge expert path, then they will find links there to how to access the training. Otherwise, they can always just pop me an email, and I can link them to how they can access that training.
Perfect. Thanks, Lenore. And maybe one final question regarding Edge. Is there any prerequisite to be eligible to apply for the Edge certification?
To become an edge expert, what's generally required is some kind of training in the built environment, or at least 3 years experience in the construction sector. While anyone can really take the edge expert training, to take the exam, which is when you actually become a certified edge expert, or an accredited edge expert, it requires more technical knowledge. So that's the background that we normally suggest.
Perfect. Thanks a lot, Lenore. And I hope our participants will head over to the Edge website and try out the tool for themselves. And you will be providing some more details on IFC's work on day 3. So we look forward to that as well. In the interest of time, I have one final question for Amira again. So what role does occupant behavior play in energy savings, and how can we effectively influence it without any heavy-handed mandates? So please, Amira.
Okay, so in sectors like the tourism and commercial offices, occupant behavior can have a big effect on HVAC efficiency. Simple action like setting thermostat to 25 degrees Celsius or turning off AC in unoccupied rooms really do add up. Instead of mandates, we can use gentle reminders like stickers and involve staff as green champions to create a culture of energy awareness. And I have seen some stickers promoting energy efficient action at the Energy Efficiency Management Office, and as well as in some hotel in Mauritius. So I think those actions are like without any heavy mandates, those are the actions.
Yeah, great. Thanks, Amira. I think those are simple enough that can be replicated in other buildings as well. So maybe if there are any building managers here today, maybe they will give it a try as well. So we are a bit over time. I'm sorry to keep you all past the agreed upon webinar timing, but I would like to now conclude the session for today. And a big thank you to all our guest speakers from IFC, from Mauritius, from Zambia, and also my colleague Amira for your time today. I think your insights were very important for the session here, and I hope that our participants had gained some interesting perspectives from this session today, and they will continue to join us tomorrow. And tomorrow we will be tackling the policy and regulatory environment that can support energy efficiency adoption in Africa. So I hope everybody will be tuning in, and Lenore, you'll be back on day 3, and Mr. Zulu, I think you're also presenting tomorrow. So I look forward to welcoming you all again, and wish you a thank you for all of you, and also a thank you for all our participants here today. I know we couldn't go over all of their questions, but it's great to see engagement from everybody. So thank you once again, everybody, and I wish you a great day ahead.